Lesson B1, Angles of a Triangle. In this lesson, we're going to look at the properties of the interior angles of a triangle. Let's take a look at this diagram. Here we have triangle ABC, so the vertices of this triangle are labeled using uppercase letters, and the interior angles are labeled using lowercase letters, A, B, and C. So we call these angles ABC the interior angles of a triangle because they are found inside a triangle and they always add up to 180 degrees. So we can say that the sum of three interior angles in a triangle is A plus B plus C equals to 180 degrees. And of course, in some other cases, these letters A, B, and C may be replaced by other letters in the alphabet or by using angle label conventions like angle CAB for angle A and so on. Example 1. Find the unknown angle. So we will look for the size of the last angle in these diagrams. In question A, I have 80 degrees, 70 degrees, and X. Knowing that these three angles will add up to 180 degrees, I can set up an equation like this. And I can first add 80 and 70 degrees together. So the left side here becomes X plus 150 degrees equals to 180 degrees. To find X, I will subtract 150 degrees from 180 degrees, which gives me X equals to 30 degrees. Question B. So here we have a right angle triangle because I know the symbol stands for a 90-degree angle. Therefore, we can say that X plus 90 degrees plus 30 degrees is equal to 180 degrees. Or X is equal to 180 degrees minus the sum of 90 and 30 degrees, which is 120 degrees. And that gives us X equals to 60 degrees. Example 2. Find the missing angles. The diagram here shows us that two sides in this triangle are equal. This is known as an isosceles triangle. In all isosceles triangles, we know that we have two equal sides and also the two base angles are equal to each other. That's why I can label the third angle in this diagram as angle B as well. So now I know that B plus 100 degrees is 180 degrees, or 2B is equal to 80 degrees. And now I divide 2B equals 80 degrees by 2 to get the size of angle B, which is 40 degrees. Example 3. Three boats A, B, and C are spotted from the lighthouse L. Determine the measures of the unknown angles. Justify your answers. So here is the diagram. Boats A, B, and C in their locations, and lighthouse L is right here. So when you look at a big question like this, make sure you focus on one angle at a time, and you look for angle properties that will help you to solve this problem. You do not need to go in the order of angle A and then angle B and then angle C. Go in any order that you think you have the most information for. So here I notice that angle A is next to angle 70 degrees, and we are told that they add up to 90 degrees. So I can calculate angle A using the relationship of 70 degrees plus A is equal to 90 degrees. Or it is 90, take away 70, which is 20 degrees. And we call this complementary angles, two angles that add up to 90 degrees. Once you have found the size of angle A, you can label 20 degrees on the diagram because this may help us to find the other angles. So now when I look at the diagram, I'm in this triangle. I know this is 20 degrees, this is 106 degrees, and I have angle B. Well, it looks like we can use the sum of interior angles in a triangle to find the size of angle B. Because 20 degrees plus B plus 106 degrees should add up to 180 degrees. So I know that B plus 126 degrees is 180 degrees. So I can subtract 180 by 126 to find the size of angle B, which is 54 degrees. So label 54 degrees on your diagram if you want to. And then we're left with the last angle to solve for, which is angle C. There are actually two ways to find angle C, but it is the only angle in the second triangle here, so it might be useful to look for the size of at least another angle. And I noticed that just like angle A, the bottom angle here plus its neighboring angle 42 degrees add up to 90 degrees. So 90 take away 42 gives us this angle as 48 degrees. And then I notice when I have 48 degrees here and angle C at the top, these are the opposite interior angles from 106 degrees, the exterior angle. So I can actually use the rule for exterior angles, C plus 48 degrees equals to 106 degrees to solve for C, which is 58 degrees. If you don't choose this method, there is an alternative, which is to find the angle next to 106 degrees because it will add up to 180. And this angle should be 180, take away 106, which is going to be 74 degrees. And then 74 plus 48 plus C is 180. So that will give you the exact same result. Okay, example 4. Can these angles make a triangle? 20 degrees, 131 degrees, and 26 degrees. Well, we're going to come up with a solution or an explanation using the famous rule. All the angles inside the triangle, or all the interior angles in the triangle should add up to 180 degrees. So when we add up 20, 131, and 26, if it adds up to 180, that's a triangle. If it adds up to a different number, then it's not a triangle. And they happen to add up to 177 degrees, which is not 180 degrees. Therefore, we can draw the conclusion to say that these angles don't make a triangle. And this is the end of lesson B1.